introduce myself. My name is Madonna. As I mentioned, recently I was decided to do a venture leading my company. Of course, I still work as an Android engineer, which is what I've been doing for the past 8 years now. Almost 7 years. I started back in 2014, building Android, not professionally, but I became professionally around 2016, all the way to now. It's been a fun journey, and over the years I've learned a lot, and I'm actually now an expert in Android. And today I want us to just look at how Swift compares to Android, because if you've worked, okay, so let me do this as the also low down the fonts. How many of us here have actually worked on either Android or iOS? Oh, pretty cool. That's amazing, I love that. So we have, because I did gauge the audience just yesterday, just walking around, and I didn't notice many people actually do React Native, which is pretty interesting. But it's good to see we have some natives in the house. I'm a React Native developer. Everywhere we're going, so okay, that's coming up.
We'll be walking over just how Android is used worldwide, and you can see here Android is used very widely in the world as compared to iOS. But then we were here where we're looking at what is UI paradigms, and in Android at Swift, the user interface refers to the visual and interactive element the users can see and interact with when using an Android or an iOS app. Now, the UI, this includes everything from, let's say, the layout and design of the app screens to the button, text fields, images, and other elements that users can interact with. Now, as you can see here, I have a summary of how the UI looks like. That is the views, the layouts, fragments, menus, and many more. Now, so what is Jetpack Compose? Jetpack Compose is a modern UI toolkit for building Android apps using a declarative approach to UI programming. It is a part of the Android Jetpack suite of libraries and tools. This was introduced in 2019 as a way to just simplify or make developers' lives easier. If you've built with XML before, you might now realize that it's much easier to build with Jetpack Compose because it makes work easier and it's written in one language, which is very, very amazing. Now, when we look at, let's say, what Jetpack Compose offers, it just allows us to build more efficient and scalable approach to UI programming, and where these UIs can be, updated dynamically based on changes to the app state, which is super great. It also integrates seamlessly with other Jetpack libraries and tools such as view models and live data, and it can be used with both Kotlin and Java programming languages. Now, I know this is a Jetpack Compose talk. What am I talking about? Swift UI. So one of the main benefits of Swift UI is that it allows developers to build UI elements using a simple and intuitive syntax, using a combination of declarative statements and Swift programming language constructs. So you can tell just looking at this Swift UI that Jetpack Compose borrowed a lot from Swift UI, because Swift definitely caters for the iOS world and Jetpack caters for the Android world. But as you can see, they're pretty similar concepts that are being now used for Android as is for Swift UI. Now, something that I know maybe many didn't know when I was doing this research is I learned that both of them were released the same year. So Jetpack and Swift UI are relatively new technology, with Jetpack Compose being introduced in 2019 and Swift UI being introduced in 2019 as well. Now, as you can see there, now more developers are using Jetpack or learning it in 2023, and also in Swift, more developers are using Swift or are learning it. So in Swift, I researched, because I've not worked a lot on iOS, but I've played around with their code, is that they normally used the UI kit, but now it's similar to what we were using XML, but to them they had the UI kit. I feel like if you've written a little bit of C# code, you might have seen something similar to the UI kit, because it's similar, just a UI that you drag and drop and makes work easier. So yeah. Now, so here I talk about what developers can use in iOS and Android. So you can look at those slides when you're just trying to compare more on what that is. Now, let's get into the juicy part, which is the code. Let's look at how the code looks for Android and iOS. So this was pretty interesting because I noticed that the code looks very similar for Jetpack Compose and Swift. So this is to mean that you can build pretty easily. So in Jetpack Compose, the text component takes a string as a parameter, which is used to set the content of the text. The style parameter is used to set the text style such as font and color and size. Yet the modifier parameter is used to set the layout properties of the text, such as adding padding and width. Now, so I think about the modifier as just a decorator, which is super cool. You can decorate all your components easily. In Swift UI, this is how it looks. See, something similar. It is not very complicated. So in Swift UI, the text component also takes a string as a parameter, which is used to set the content of the text. Additionally, we have modifiers where we can see they're using the set font, padding, and other styling properties to the text. So they don't call it a modifier, but as you can see, they're also decorating their text, which is pretty cool. Now, let's look at a text field. So this is how an outline text field looks like in Jetpack Compose. As you can see here, the outline text component takes in a value and a non-value change parameter to manage the state of the text field. The label parameter specifies the label text that appears above the text field, and then the modifier parameter is used to specify the width of the text field. Finally, the border parameter is used to specify the color and the width of the outline. How does Swift look like, or iOS look like? Wow. So this was a one-liner which was pretty interesting. So in this example, the text field component takes in a string parameter that specifies the label text that appears above the text field. The text parameter is used to manage the state of the text field. And then finally, the text file style modifier, I think of it as a modifier, is used to apply a rounded border style to the text field, because you see there we've said rounded border text field. Now, we will not be doing justice if we don't look at the buttons in iOS and in Android. So in Jetpack Compose, the button component takes an on-clicked lambda as a parameter, which is executed when the button is clicked. Now, the modifier parameter again is used to set the layout properties of the button, such as padding, width, and so many things that you can actually just look into what you can do. And then text component is now used to just set the text displayed on the button. For instance, is this button will be called Jetpack Compose button. So whenever you see this button, you'll see a Jetpack Compose button, and then you can click it and do whatever you would want to. How about in iOS? So in iOS, as you've seen, looks pretty similar, pretty interesting. So in Swift UI, the button component takes an action closure as a parameter, which is executed when the button is clicked. Now, the text component is used to set the text field on the button. An additional modifier are used to set the padding, background color, and corner radius of the button. And one key difference between the two implementation, that is in the Jetpack Compose, uses Kotlin code, while Swift UI just uses the Swift code. But as you can see, this looks way similar to the slide before. If you asked me, look at that. And then look at that. No? So you can now easily become an iOS and an Android developer without even knowing. In the new world now. Now let's just look at how columns are made in Android. So in Jetpack Compose, the column component is used to arrange child component vertically or any way you would want to. Now, the image component is used to display an image, and the text component is used to display a text. The modifier parameter again is used to set the layout properties of the column and its child components, such as padding and size and other things. And as you can see there, we just have an image that is already included in the column and the text. Now, in Swift UI, this is how they do it. Now, in SwiftUI, they use the VStack component, which is used to arrange child's component vertically. Now, the image component is used to display an image, and the text component is used to display the text. Additional modifiers are used to set the layout and the styling properties of the column and its child component. And individually, you can also use haystack, VStack, haystack, which is just horizontal stack, VStack, which is definitely just vertical stack, and ZStack adds simple views. So haystack position is horizontal, and then VStack again just vertical, and finally ZStack just overlays the views on top of one another. Now, nowhere we're not looking into the rows, so let's look at the rows right now. So when we're looking on rows, you'll notice a few things, which is in Jetpack Compose, the row component is used to arrange child components horizontally. Now, the image component is used to display an image, and the column component is used to display two text views vertically. The vertical alignment parameter is used to align the child component vertically, while the modifier parameter is used to set the layout properties of the row and its child components. Now, let's look at iOS. So, in SwiftUI, the haystack, we looked into that previously in the previous slide. The haystack component is used to just arrange the child components horizontally again, and the image component is used to display an image, as you can see, and the VStack component is used to display the two text view vertically. And if you're a visual person, you can visualize this. And additionally, modifiers are used to set the layout and the styling properties of the rows and its child component. Now, if you want to do a group, this is how you can do a group in Android, and then in SwiftUI, that's how you can do it. So in SwiftUI, it's a little bit interesting because they introduce this struct. And if you've written C or C++, you might have had the word struct. I figured the idea must have been borrowed from there. But as you can see here they have this struct, and in SwiftUI, the red U button component is not available out of the box. So the code includes a custom implementation, and that is the selected option variable is used to keep track of the currently selected option. Now, the options are listed in the for each loop, as you can see there. The selected option variable is used to keep track of the currently selected option, and the options are listed in a for each loop, with each option displayed in a haystack component with a custom radio button and a text view. In SwiftUI, a struct is a fundamental building block used to define a user interface component. A struct is short for structure, which is a way to define a custom data type in Swift. And in SwiftUI, structs are used to define the properties and behavior of various UI components such as views, buttons, and labels, and each struct is defined using a struct keyword and contain a set of properties and methods that defines its behavior. Now, if I move to my next slide, you will see now we're talking about a card, which I think they're very, very popular these days. And I actually had a funny conversation with someone who asked me, hey, what's the difference with iOS and Android these days? It feels like iOS and Android, they're borrowing the same things, or they look pretty similar. And I was like, yeah, I feel like that is so true. And I think why it's because the cards, I feel like, I don't know who came up with the cards first, but the cards have definitely revolutionized mobile. So in this example, the card component takes in a modifier parameter to specify the size and position of the card. Now, the elevation parameter is used to add a drop shadow to the card, while the shape parameter is used to round the corner of the card. The card content is defined within a column component. As you can see there, we have text, card title, text, card content. And if you can visualize this, or if you get time to run this particular small snippet code, it will be pretty good to just see how that would look like. Now, in iOS, this is how it would look. So in this example, The card is created using a Z-stack component with a rounded rectangle shaped using a rounded rectangle component. The fill modifier is used to set the background color of the card to white, while the shadow modifier adds a drop shadow to the card. Now, the card component is defined within a V-stack component, which is then centered within the card using the pattern modifier. As you can see there, we have a pattern modifier. Now, I've spoken so much about Android and iOS and how they compare, and now I know you're wondering, how about the people that are doing Kotlin multi-platform or Flutter or React Native? What is happening here? So as you can see in this example, I'm just going to walk you through how KMM is much easier to build with and pretty easy to learn these days, because as you've seen, when you compare the two codes, they look very similar. So it means you can easily build for both platforms if you wanted to pretty easily. So in this example, the card interface, that is in KMM, is defined using the expect keyword. Now, as you can see, we have expect, which indicates that it is a common interface that will be implemented differently on each platform. The card interface takes in a title and a content parameter, which can be used to specify the title and the content of the card. Now, the create card function is used to create a new instance of the card interface, and it returns an implementation of the card interface. On the Android platform, the card impl class is used to implement the card interface. Now, the actual keyword is used to just indicate that this class provides an actual implementation of the card interface on the Android interface. And as you can see here, we also have another example where we have the create card function, which is used to create a new instance of the card interface, and then the card view is a custom of a view that is used to display the title and the content of the card. The title text view and the content text view properties of the card view are used to set the text of the title and the content of the card. So overall, create a card in Kotlin multi-platform requires defining a common interface using the expect/actual pattern and providing platform-specific implementation of this interface. So once this interface is defined, you can use it to create cards in a platform-agnostic way, which is super cool. Now, that said, we will explore more of this just through following the resources. So this is where you can learn more about Jetpack Compose and how about building Swift UI views, and this is my book. I talk about just building views in Jetpack Compose, and I walk through so many recipes which I think they're pretty helpful. So if you get a chance, check it out, and don't forget to connect with me there. Those are my social, and that's me on LinkedIn. And thank you very much.